Hey guys, this is Mr. Pilla here. Today is Monday, May 18th, 2020. And before we go into what it is that we're learning today, I do want to make it the point that I'm going to be referencing a lot of what we learned during weeks 8 and week 9 because everything from week 8 all the way until week 11, which is next week, is all going to be a part of a unit, right? This is actually how, if we were in school, this is what you would learn as an entire unit. So I'm trying to keep it that way during these times of remote learning because it is important that, in order to fully grasp um, these topics and why we learn about them, you need to understand how they all connect and fit together. Okay, so let's go back to weeks 8 and 9 and discuss what we've learned so far. Okay, early on during week 8, we learned about fossil fuels. Now, what are fossil fuels? Fossil fuels are coal, oil, natural gas. They're the remains of organisms that lived a long time ago, like millions of years ago, right? And we use these fossil fuels to supply us with cheap energy, okay? Energy like electricity, cooking, transportation, heating, etc., right? So the big thing about these fossil fuels is that they supply us with cheap energy, which is perfect because we have a huge demand for energy. Okay? Just imagine life without your cell phone. Here's the thing about those fossil fuels, though. Those fossil fuels are non-renewable. Non-renewable means that once we use them up, they're gone. We can't get more of them. We have a limited supply of fossil fuels. The other major concern with fossil fuels is that they create air pollution. And that air pollution directly ties into our discussion on climate change. Now, we've talked about with climate change, essentially the causes and effects of climate change, right? We discussed the greenhouse effect and how its sole purpose is to keep our planet warm, which is a good thing because without it, our planet would be absolutely freezing. Life wouldn't be able to exist on it. Um, but the issue is with climate change and with our greenhouse effect is actually working overtime. It's working harder. The reason being is that the greenhouse gases that are responsible for the greenhouse effect, um, just like how if you took those greenhouse gases away, things would get cold. If you add additional greenhouse gases, things get hotter. Okay? Now, where are those additional greenhouse gases coming from? Well, a majority of those additional greenhouse gases that are causing climate change come from the burning of fossil fuels. When you burn fossil fuels, it creates carbon dioxide. Carbon dioxide is a major greenhouse gas. So when you burn those fossil fuels, they release a lot of carbon dioxide, a lot of extra carbon dioxide that winds up in our atmosphere. And because we have all that extra carbon dioxide in the atmosphere, the greenhouse effect works overtime. It works in overdrive, okay? So ultimately, what we want to start discussing now is, okay, we know what's causing climate change. We know if climate change is allowed to continue, what the consequences of climate change are. Things like flooding, rising sea levels, unpredictable and severe weather storms and patterns, droughts. It'll impact our agriculture. It'll impact our biodiversity because it'll cause species to go extinct. We know there's a lot of consequences involved with climate change. Now what we have to do is figure out, okay, how can we prevent climate change? Well, not necessarily prevent because it's happening. We want to be able to reduce, get rid of it, go back to more of a status quo, right? So now what we have to focus on is, okay, how can we eliminate climate change? Well, if we think about it, if we want to get rid of climate change, the main way that we should go about that is to get rid of the thing that's causing it, right? Well, the major cause of climate change, as we discussed, is the burning of fossil fuels. Okay, so let's stop burning fossil fuels. That'll stop climate change. Well, it's not that easy because, like I had said, fossil fuels supply us with energy, electricity, cooking, transportation, those kinds of things. So if you're going to stop burning fossil fuels, you won't have that energy anymore. So ultimately, and this is what we're mainly going to focus on this week, is are there alternative ways of getting energy besides fossil fuels? Because if we can determine these alternative sources of energy, we can stop using fossil fuels, which will then in turn reduce the amount of carbon dioxide we're putting in our atmosphere, which will then reduce the effects of climate change. Sounds interesting, right? So, again, that's what we're going to focus on this week. Are those alternative energy means? Okay, let's get started. Today we're going to be talking about nuclear energy, all right? Now, before we go any further, I want to make this clear, is that think back to when we learned about fossil fuels. You learned about the pros and cons of coal, oil, and natural gas. The pros mostly being that they were cheap sources of energy. The cons mainly being that they were non-renewable and they caused climate change. With each of these forms of alternative energy that we're going to talk about this week, they're all going to come with their own pros and cons, their advantages and disadvantages. And that's what we're going to focus on with all of these energy sources, because it's important to understand that, yes, these alternative energy sources will reduce climate change. But there is a reason why you don't really see these energy sources as predominantly as fossil fuels. And that really goes into their disadvantages. So we are going to talk about their advantages, but we also are going to talk about their disadvantages. All right? And where I would like to start with our discussion on nuclear energy is, what is nuclear energy and where is it found and how do we get to it? Well, nuclear energy is ultimately energy that is locked away within the nuclei of atoms. Okay? If you think about what an atom is made up of three things: protons, neutrons, electrons, right? The protons and neutrons of an atom make up the nucleus. If you take a look at the picture to the right, you see the picture that represents an atom, okay? The blue and the red in the center are the protons and neutrons. They make up the nucleus. And the electrons are those gray balls that are rotating around that nucleus. The energy of an atom is stored within that nucleus, where the protons and neutrons are. Ultimately, our goal in nuclear power and nuclear energy is to unlock that energy that's found within those nuclei. Because even though they are atoms, and atoms are, very small, they're our basic unit of matter, there's a lot of energy stored within those nuclei, okay? And ultimately, we want to unlock that energy in order to, supply us with our own means of energy. So how do we unlock that energy? Well, there's two main ways of unlocking it: through fusion and through fission. We're mainly only going to talk about fission because fusion, the technology isn't necessarily well developed, and not many power plants, if any, really run off of fusion power. But the idea behind fusion is that we are fusing two atoms together in order to unlock their energy. That's all I'm really going to talk about with fusion. With fission, it's the opposite. What we're doing with fission is we are splitting our atoms. Ultimately, what we want to do is we want to take the nucleus of an atom, specifically uranium, and split it. And like cracking an egg, it'll unleash the energy found within. Let's take a look at our next slide in order to better understand this process of fission. And here is a picture that represents the process of nuclear fission, okay? So the first thing I want you to notice in this picture is these larger spherical shapes. These are our uranium-235 atoms. Now, I didn't mention this before, but the reason why we use uranium when producing nuclear energy is for two reasons. One, uranium contains a lot of energy stored within its nucleus, okay? So if you can crack open that nucleus, you can unleash a lot of energy. The second reason is uranium is pretty unstable in the fact that it's not that difficult to unleash that energy. Okay, the actual presence of all that energy makes it really unstable and like just ready to burst. Kind of think of like a water balloon that you filled up to like the very brim, and just the slightest touch of it is going to cause it to pop, right? That's kind of what uranium is like, where just the slightest impact is going to allow it to burst and fissure, okay? So how is it that we're going to split these uranium atoms? How is it that we're going to cause them to burst to be able to release their energy? Well, take a look over here. What we do is we allow these neutrons, okay, these neutrons that sort of float around in this space, that same space that's occupied by these uranium atoms, we essentially allow these neutrons to impact these uranium atoms. Okay, almost like a bullet that's flying in and shooting at the uranium atom, that neutron comes in and strikes the uranium atom. When the uranium atom is struck, the result is a fissure, where you have essentially smaller atoms that are formed, okay, along with other debris like other neutrons, okay? And when this split occurs, it releases the energy stored within the uranium, okay? Now, this is not the only thing that results that is a positive thing. Yes, we wanted that energy, but the other thing that comes about with this is it actually begins a chain reaction where the debris, the neutrons that are now flying off of this uranium atom that just burst, well, look where they're going. They're headed towards other uranium atoms. And when they strike these other uranium atoms, the same thing will happen. Those uranium atoms will fissure, they will split, they will release their energy, and they will also send off flying debris. And that flying debris is going to impact other uranium atoms. So in this process, we have just a bunch of uranium atoms splitting and causing debris to fly everywhere, and that debris goes on and hits other uranium atoms, causing them to split, and the process just continues, okay? And that's the process of nuclear fission. Now, in the next slide, what we're going to talk about is how we take that nuclear fission, okay, how we take that nuclear energy and make it usable. And here we have the diagram of a nuclear power plant. Now here's the thing about nuclear energy, it's really only useful when creating electricity. You can't really get any other forms of energy out of it. For example, you're not going to take your car to a gas station and fill your car up with uranium to use nuclear power. You're not going to cook with uranium for its nuclear energy. Those kinds of things aren't necessarily safe. But the good thing is, electricity is a very versatile form of energy, where we can use electricity in those other fields of energy. We can use electric cars. We could cook with electric appliances, okay? So we can still do those things with electricity. And the nuclear energy supplies us with that electricity, okay? So when you're looking at this diagram, it probably looks very similar to you because it does. It looks very similar to the way a coal-fired power plant works. Here's the biggest difference, though. With a coal-fired power plant, we're lighting coal on fire. That's our fuel source, okay? In this instance, with nuclear power, we're not lighting anything on fire. We're using uranium. And that uranium is allowed to undergo nuclear fission, and that's our fuel source. Okay, so let's go through this real quick because it really works the same exact way as a coal-fired power plant. It's just the fuel source is different. Okay, so what happens is the uranium here undergoes nuclear fission. That creates enough heat. Okay, the energy released from that process creates enough heat, and that heat energy is used to heat up water and turn it into steam. That steam is then pushed against a turbine, which causes it to spin, because remember, turbines spin. The turbine is attached to a generator, and when the turbine spins, the generator spins, and when the generator spins, that's what creates our electricity. And the leftover steam is then allowed to condense back down into water. So see, it's really the same process as a coal-fired power plant, it's just our fuel source is different. Okay? Now what I want to get into is I want to start talking about the advantages of nuclear power. And when we talk about the advantages of nuclear power, the biggest advantage there is the fact that it does not create air polluting gases. There's no air pollution when it comes to nuclear power. I'm sure you guys can think of a nuclear power plant from the outside, and you've seen these big towers before and the stuff coming out the top. That stuff coming out the top is not smoke, it's steam. Okay? When we create electricity through nuclear power, there's no air pollution involved. Unlike coal, that when you burn coal, right, it creates all that carbon dioxide and all that air pollution. Nuclear power doesn't create any of that, which is fantastic because the whole point of us learning about nuclear power is, remember I said we got to find alternative forms of energy that will help us stop using fossil fuels. And if we stop using fossil fuels, then we're going to stop polluting the air with carbon dioxide and we'll slow down climate change. This is a huge bonus for nuclear power. The fact that if we use more nuclear power, then we're not going to create the carbon dioxide necessary for climate change. And we're going to slow down climate change. And that's a huge, huge, huge advantage. Okay? Another big advantage of nuclear power is that, let's say you're a country that doesn't really have access to fossil fuels, you can use nuclear power instead to supply you with enough energy needed to sustain your energy needs. Okay? So, those are really the biggest advantages of nuclear power, but like everything else, it comes with its advantages and its disadvantages. And there's reasons why we don't use a whole lot of nuclear power around the world today. So let's talk about why it is that we don't really use more energy, nuclear energy around the world. Okay, these are really the disadvantages of nuclear energy. One of the first disadvantages of nuclear energy is the fact that it is non-renewable. Okay, and remember we said non-renewable means that you have a limited supply of it, and once you use it up, it's gone. So compare that to fossil fuels. Fossil fuels are also non-renewable. So you're not really, getting any worse compared to fossil fuels because they're non-renewable as well. Um, and remember, this still has the advantage of not creating any sort of air pollution. So the fact that it's non-renewable when you're comparing it to fossil fuels is not as big of a deal. It's still a disadvantage because eventually we will run out of it. Let's say if we decide to focus primarily on nuclear power, we will eventually run out of it, and then we'll have to come up with another solution. So it is a disadvantage in that sense. The next major disadvantage to it is that nuclear power plants are expensive. Okay? They're very expensive to build and maintain. In fact, they also, because of the process needed to build a nuclear power plant, they actually take a very long time to even be constructed. And it's a lot of time and it's a lot of money to just construct a nuclear power plant. Here's the thing. The biggest disadvantage, and I honestly believe this is the biggest disadvantage, and even though we have one more disadvantage to talk about after this, which is the one that a lot of people are primarily concerned about, I really consider this one to be the biggest disadvantage, is that when you use nuclear power, okay, when you use uranium in the nuclear energy process, it creates a nuclear waste product, okay? Now, the thing about that nuclear waste product is it's nuclear, it's radioactive, it's dangerous. So it's not like it's something that you can just dump down the sink or just something you can throw in the trash, right? You can't do anything like that with it. So what do you do with it? Well, as of now, we have to store them in these big, large, thick containers where none of that radiation is going to leak out. Okay, great, but what do you do with the really large, thick containers? We don't really know. In fact, a lot of nuclear power plants just kind of keep them on site in their backyard and say, yep, there they all are. Some places store them in, warehouses. There was actually at one point a recommendation of creating a facility out in the middle of the desert in the United States, like out in Nevada, in the middle of this like mountain, right? And what they were going to do was they were going to use that as a facility for storing all their nuclear waste. But that necessarily wasn't the best idea either. It didn't happen, but it really is not the best idea because think about it. Let's say you're in New Jersey and you have to transfer all of your waste across the country. It's not really that great of an idea, okay? Also, storing all that waste in one location can cause some pretty major problems as well. If for whatever reason, like something were to go wrong there, okay? So again, that's really the biggest disadvantage to nuclear power. But there is one more disadvantage, and this is probably the one that a lot of people fear, right? It's the fact that if you have a poorly designed power plant, there is the potential for a meltdown. One of the biggest examples of this is Chernobyl. In 1986, the Chernobyl reactor, the Chernobyl nuclear power plant, exploded. And the explosion resulted in a lot of destruction and damage to the surrounding area. In fact, all the people that lived in the surrounding area had to evacuate their homes, and they were never allowed to return. In fact, today, no one is allowed to live in the surrounding area because of all the radioactive material in the area. If you were to try to live in the surrounding area, you'll get sick and die, okay? And scientists are really saying that it's probably like another 1,000 years before people can live around Chernobyl again. And that's a really terrifying thing. But here's why I don't consider it to be the biggest disadvantage. Because these meltdowns really don't occur that often. When they do occur, it's really major. But Chernobyl is really a one and only example of something like this happening on this kind of scale. There have been other meltdowns before, and actually there's not even that many other meltdowns. And all of those other meltdowns have kind of been contained to this point. But, like I said, the biggest reason why people fear nuclear energy is because of things like Chernobyl. Okay? So, in my next slide, I do want to show you some pictures of what happened with Chernobyl and some of the resulting images. Okay? And here we have some images that resulted from Chernobyl. Some of these images you might have seen before if you've ever, watched a documentary or looked this stuff up. Here in the top left, we have the control room. Now, the story of Chernobyl, the whole reason why, it exploded the way it did, was because they were running a safety test. And isn't that really ironic? They were running a safety test and then this catastrophic thing happened. But ultimately, they were running a safety test, and really the reason why this happened was because of two things during that safety test. One, they had outdated and kind of faulty equipment in their reactors. But two, the people that were running the operation, they were undertrained and really didn't know what they were doing at the time. So they kind of just winged it. And they kind of created this perfect storm of events that led to this explosion. Okay, and that all happened in this control room. Here in this other picture to the top right, we have an image that shows how it exploded. And here's the thing. These nuclear reactors are not supposed to explode. Okay? If a meltdown occurs, it doesn't result in an explosion. So that's what was the really interesting thing here, was the fact that it actually exploded. Okay? Here in the bottom right, we see how much of a ghost town the surrounding area has become. Okay? Like I had said, no one can live here for like another 1,000 years. So this whole area has just become a ghost town where just nothing exists. I mean, you got plants and like animals that run through and whatnot, but like you can't live there because of the amount of radiation that there is. It's not safe for people to live there. People do visit, right? You can actually go there in certain times in certain areas where you can be there for a certain amount of time and not really get affected. But if you stay there for any extended amount of time, then things start to get bad. Now, this picture to the bottom left here is actually a really interesting one because ultimately they're trying to speed up the process of um, getting the area habitable again, right? And the way that they're doing this is they're actually building a large concrete dome over the power plant to kind of seal everything in. All right. And if they're able to seal everything in, it'll allow the surrounding radiation to work its way through a lot quicker. And then that radiation will kind of dissipate and disappear a lot quicker. Okay. So I thought that part was pretty interesting as well. I'm not entirely sure of the progress they've made on this dome. I don't believe it's done yet, but it might be something worth looking into for you guys. All right. All right, and that's everything I have to talk about with nuclear power. So we've discussed the advantages and disadvantages of nuclear power. Okay. Now, this is only our first form of alternative energy we're going to talk about. We're going to talk about more forms of alternative energy in the week ahead. All right. If there's anything you didn't understand in this video, just you can rewind, watch it again, keep watching it until like you get it. Or if there's any questions you might have or something I can help you with, please contact me as soon as you can, and I'll try to help you the best I can. All right, guys? All right. Until next time, see you then.